Hello everyone. Previously we had solved uh, 8 problems on hash map and hash set, right? So now we'll be solving some problems on 2 pointers. So let's solve the problem number 125, valid palindrome. So just go through the problem and also try to understand the problem with the example. They have shown you the example as well. Try to understand the problem with the example. I'll just summarize the problem for you so that it is easier to understand. So what the problem states here, we are given a string S and our task is to determine if it is a palindrome after the transformation. So we are given a string S. You can clearly see here, we are given a string S and our task is to determine if it is a palindrome after the following transformations. We have to convert all the uppercase letters into lowercase letters. The first thing is we have to convert all the uppercase letters into lowercase letters. This one we have to remember and remove all the non-alphanumeric characters. So while I say alphanumeric characters, except alphanumeric characters, we have to remove everything, whether it may be comma, whether it may be punctuations, whether it may be anything here, colon, anything. We have to remove everything except non-alphanumeric, except alphanumeric characters, whether it may be spaces, commas, punctuation marks, etc. Anything it may. So, and also a palindrome reads the same forward and backward. So we know that a palindrome reads the same forward and backward. So in this problem, we'll be focusing only on the alphanumeric characters as I have said, and we need to ignore all the characters. Right? So let's initially go with the approach. Let's discuss the approach. Then let's go with the edge cases and then write the code. Right? So just give me a sec. So let's discuss the approach step by step. So here first we'll be going with the 2-pointer approach. So I'll just give here. We'll be going with the 2 pointers. So we'll be making use of the 2 pointers. One that will be starting from that will be at the beginning, nothing but we'll be making use of it as left, and one starting at the end, nothing but the right here. So one at the beginning, nothing but will be giving left, and one at the end, nothing but right here. This one beginning and this one at the end, right? And the second step is we will skip all the alphanumeric characters. So skip all alphanumeric characters. This is one thing. We move the left pointer to the right and the right pointer to the left here. You just remember, we'll be moving the left pointer to the right and also the right pointer to the left, skipping all the non-alphanumeric characters. We'll move the left pointer to right and right pointer to left, and we will skip all the alphanumeric characters. I'll just give ANC here. ANC is nothing but alphanumeric characters here. This one we have to keep in mind. This is the second step, and the final step is we have to check for the palindrome. So at each step, nothing but here we have to check for the palindrome, or we will check for the palindromes. Just give me a second here. So here at each step we check if the characters at the left and right pointers are equal. So we will be ignoring the cases. We will check if the characters at the left and the right pointers are equal. If they are not equal, we will return false. If they are equal, we will continue checking until the pointers meet or cross. So that's what we will be doing. So again I'm telling, we will check if the characters at the left and right pointers are equal. We will check the pointers left and right are equal, right? This is one thing. If they are not equal, we will, if they are not equal, then we will return false, right? So if they are equal, we will continue checking for the pointers until the pointers meet, right? If they are equal, we will continue until pointers meet. So basically, this is the approach that we'll be going with. So this one will clearly understand while we write the code, right? So let's initially go with all the edge cases, then let's start writing the code, right? So let's go with the edge cases. So I'll just give here edge cases here. So the first one, the first edge case, let's consider the empty string as input. So here we are considering the empty string as input. So the output will be true here. Why the output will be true here? We know that the string is considered as a palindrome because there is nothing to compare here. So the output will be true here. So this is for the empty string. So this is the first edge case we will consider. So next, let's go with the second edge case, nothing but string with only non-alphanumeric characters. So we are going with string with only non-alphanumeric characters right here. Let's consider this one. So the output will be here true. So why the output here is true? Basically, after removing the non-alphanumeric characters, the string is empty and thus it is a palindrome. So we will be removing the alphanumeric characters. We will not be considering the alphanumeric characters at all right here. This is an alphanumeric character. So non-alphanumeric character, this one. So after removing this one, we'll be ignoring this one. After removing this one, the string will be empty. So the output will be true. This is the second edge case. And what will be the third edge case here? So single character string, nothing. When I say single character string, we'll be considering this one, A, right? So this one will be true because a single character is always a palindrome. We know that one. So this one will be true. So this one will be single character string. This is one thing. The second one was for string with only non-alphanumeric characters. Here I'll just give only non-alpha numeric characters, right? This is for the second one. And third one for we saw for the single character string. Let's move on with the next edge case. Fourth one, case sensitivity. So let's go with the fourth example. While I say case sensitivity, let me make use of the capital letter as well as the small letter here. A, B, A. This here, the output will be true here. Why the output will be true here? The palindrome check should ignore the cases. So every case should be considered as this one, lower letter case itself, right? So ABA should be considered as a palindrome here. This one should be considered as a palindrome. So this one is nothing but case sensitivity. This is the fourth edge case. Let's move on with the fifth edge case. So let's go with the string with the numbers. I'll just give some random number here. Let me consider 1, 2, 3, 2, 1, something like this. So here number should be treated as the letters itself for the palindrome checking. So again I'm telling number should be treated the same as letters for the palindrome checking. So you can check this one 1, 1. 1, 2, 3, 2, 1. Here also from if we read from the backwards, then also it is 1, 2, 3, 2, 1. So this is a palindrome. So we should get the output true here, right? So this is for the string with numbers. String with numbers, right? This is the fifth edge case. So let's move on with the next edge case. Nothing but the sixth one, string with spaces. Let's consider here the example one, a man. So they have given here a man, a plan, and a canal, and Panama they have given here, right? This example, let me consider here. Same thing. After removing all the non-alphanumeric characters, we have to spaces and punctuation should be ignored here, right? And the resulting string should be checked basically. So we have considered this example, right? After removing the spaces and punctuations, we get this one, which is basically a palindrome, right? So let's move on with this one. This one is true. Why? Because the spaces and punctuation should be ignored and the resulting string should be checked. Basically, this is true. You can read from the backwards as well. This one is a palindrome basically. The final one is non-palindromic string. So this one was for sixth, and this one string with spaces. And the final edge case is for non-palindromic string. So let's consider this one itself. Example 1, erase a car. So here the string is not a palindrome. Once we remove the spaces and punctuations, we will remove the spaces and punctuations. So after this, we'll be getting the output false here. So this is one of the edge case, nothing but non-palindromic string. So these are the 7 edge cases that we need to consider basically, right? So first one was, I'll just come here. First one was for the empty string. Second one was for only non-alpha numeric characters. Third one was for single character string. Fourth one was for case sensitivity, we saw. Fifth one was for string with numbers. Sixth one, we went with string with spaces. And the final one was for the non-palindromic substring. So I hope every edge case is clear. So I'll just so let me just delete this one and let's start writing the code. Just give me a second here. Yeah, I'll just let's start writing the code here. So I'll just come here. Initially what I'll do, just give me a second here. So let's write the code. Here first thing I'll be doing here is let's consider the helper function to check if a character is alphanumeric or not. I'll just make use of function here. I'll just give is alphanumeric. So we are just checking whether we are making use of the helper function to check if the character is alphanumeric or not. Let me pass the parameter char here. Just give me a second. This is lagging here. Oh, this is lagging too much. So first what we'll do, we'll get the ASCII value of the character. How can we do that? I'll just make use of the variable name code. Let me give here char dot. Let's make use of the char coded to get the ASCII value of the character at 0. So let's return this one quickly. So here I have considered code, right? Code greater than or equal to 48 and code less than or equal to 57. So the character code or the ASCII value for 0 to 9 starts from 48 and ends at 59. Here we are just checking if it is present between 0 to 9, right? Here, this one, just for the reference. So next, we have to check for the this one, uppercase letters as well as the lowercase letters as well, right? So for that one, I'll just be giving here greater than, but let me do one thing. Let me copy paste this one and let me change the numbers instead, right? So yeah, let me copy paste this one. So here this is for the uppercase letters. I'll just go with 65 to 97 here. Sorry, 90. Sorry. This has to start from the for the lowercase, it starts from 97 and it ends at 122. So this is fine. Next, we will initialize the 2 pointers at start and end of the string. We had discussed the same thing during the approach, right? So I'll just give here left equals 0, right equals length of the S. This is fine. What we are doing here, we are initializing the 2 pointers at the start and end of the string. So after that, we have to continue as long as the left pointer is before the right pointer, right? For that one, let me quickly write here while condition left less than right. So we have to skip the non-alphanumeric on left. Also, we have to skip the non-alphanumeric on the right. How can we write that? Again, I'll just make use of the while loop. While left less than right and not of, I'll just make use of this function name here. Here, non-alphanumeric s of left. If it is, then let's increment the left pointer. So we are skipping the non-alphanumeric on left, right? So then we have to skip the non-alphanumeric on right as well. Same thing. Let me copy the same thing and make the changes here. Just give me a second here. Yeah. Left is and right. This one, instead of left, let me change this one to right. And instead of incrementing the left, I'll just give here. Let's decrement the right here. This is fine. So next step is we have to compare the character set left and right pointers after converting to the lower case. So this is important. So every letter has to be in the lower case. So first we will be comparing the character set left and right pointers after converting them to the lower case. So this is simple if condition. If s of left, I'll just make use of the built-in this one to lowercase here. So s of right to lowercase. This one, let me return false here. This is fine. Let's finally move the left pointer inwards and the right pointer also inwards. Let's move the left and the right pointer inwards. So here increment the left and decrement the right. Nothing but incrementing the left and decrementing the right pointer. Finally, if all the characters match, if the string is said to be palindrome, right? So that one we have to give here. Just I'll return true here for that. So this is it. Let me format this one once. Let's run the code now. Let's see whether this works or not. Oh, this is not a function. This is saying here. Let's check. So yeah, what mistake I have done here is this is not a function here. We have to mention or here, right? Or this one or this one. So let me write here. We are checking from 0 to 9 here. For this one, we are checking from checking if capital A to capital Z. Same thing let me give here as well. From small a to Z here. This is fine. Let me format this one once again. Let me run the code. I hope this works now. I hope cannot read properties of undefined char code at line number 3 here. So what mistake I have done here is in the line number 11, you can clearly see here, I have considered length. So length starts from 1, right? So for the last one, we have to consider length minus 1. So I made this mistake. Let me format this one and hit the submit now. So now we are getting the correct output. right? So the code works absolutely correct. So I hope this is clear. This was the mistake here basically. So this has to be s.length minus 1, right? So this is fine. Now the code works absolutely correct. Let's discuss about the time and space complexity very quickly. Just give me a second here. So what will be the time complexity here? The time complexity will be big O of n. So why the time complexity is big O of n here? Because we are iterating through the string once with the 2-point approach, right? So we are iterating we are iterating through the string only once with the 2-pointer approach. So the overall time complexity would be big O of n. So we know that n is the length of the string, right here. So I'll just quickly come here. Let me give here big O of n. And what will be the overall space complexity here? The space complexity would be big O of 1. Why the space complexity is big O of 1, not the big O of n here? Because we are only using a constant amount of extra space for the variables like left and right that we have considered here. This one, left and right, and also the helper function is alphanumeric. This is the helper function, right? So we are only using the constant amount of extra space for the variables left and right, and also the helper function. So the overall space complexity would be here big O of 1. So I hope this is completely clear. For now, this is it. Thanks for watching, guys.